You must be thinking that you're going to go through something. I can do a couple of examples for you of things that I think are priorities, but beyond that, let's do a tree change. Sorry, that's better. That. Okay, so who'd like to go first? Who has a particular question that we can go with? Yeah.
Hi, Jason. Can you hear me?
Yeah, go ahead.
G'day. I was at your workshop last night, and you mentioned the discriminant, and it seemed pretty straightforward: b squared minus 4ac. But for me, it's been gee whiz, like 8 years since I last looked at the quadratic equation. So I'm wondering if you could use an example of using that just to
Yeah. Okay. No problem.
just
That's
to
good.
identify a quadratic and whether it has solutions or not.
Okay. So what I'll do is I'll do the cheat method. So if I take, it doesn't matter whether it's a simple one. I'll do a couple of examples. So if I do x minus 2, I'm starting out by cheating. Okay, x plus 4. And I'm going to do the FOIL. So this is my study method recommended to you. Okay, so we'll get x squared. We'll get 4x minus 2x. And we'll get 4 2s are 8. So this is the study method. So you can put random numbers in those brackets up here. These can be anything you like. And this is your study method. Okay, so 4 apples minus 2 apples is 2 apples. And so there's your quadratic. So I can draw a line under that and say that's how I cheated. Okay, and the question becomes then, what do I know about this quadratic? Well, because we cheated, we already know the solutions. We know that we take x and we know we take the opposites. So at 2 and minus 4, this thing has y-intercepts. Okay. Sometimes it takes a little while for it to. Okay. So let's get. Oh, sorry. I'm making a couple of those things out. I've always found this a bit interesting with. Okay, so we know, according to this, because we took the opposites, at 2 and minus 4, and it cuts the y-intercept at minus 8. So it's not symmetrical, because if we go 2 there, we'd go minus 2. So 4 minus 2 is 6. So 3 back would be a 1. So it's symmetrical there. I don't know what that value is at this point. But if we go up, that's pretty much what we've got. Now, I did it the cheap way. Okay, that's not the way I taught you. The way I taught you was to consider it like this. So let's do it again. Take the coefficient of the middle term, halve it, take that and square it, which seems ridiculous, but anyway, just following procedure. So 1 can be considered a square number. So if we take the two terms that we're interested in, plus 1. Now, we can't just willy-nilly plus a 1, so we've got a minus a 1, and we can't forget our minus 8, so we bring that down. This is a perfect square, this thing here. So we've got x squared. I'm leading to the practice that you need for the quadratic formula, and the discriminant is coming up, okay? So I haven't ignored you. The number we want is probably 1 with a plus. So x squared, tick, x squared times 1 times 2, 2x, tick, 1 squared is 1, tick. So -8 minus 9 is equal to 0. Okay, so this is the kind of bit now that we start to get closer to the quadratic formula. So if I undo, if I take the square root of both sides, taking both sides into account, this will undress like this. Now the square root of 9 is 3, so I'll change that on the next line. We're going to subtract 1. So x is going to be equal to -1 plus or minus the square root of 9 is 3. Okay, so -1 plus 3, comma, -1 minus 3. So if we do those two sums, -1 plus 3 is 2, -1 minus 3 is -4. If we go back to the beginning, that's what we had, 2 and -4. So we can read off directly the result. Now the similarity of that to what we do with the quadratic formula is really at this point here. Okay, we're really at this point here. So what we'll do is we'll take it back, x squared, 2x minus 8. And with that, shadow that as ax squared plus bx plus c. So the discriminant is b squared minus 4ac. So b is 2. 4, a is 1, and c is -8. It's better sometimes to use brackets. Okay, so what we've got is 2 squared is 4, take away. Now, put a bracket in, 4 times -8 is what?
-32.
-32. Now, the reason that I put the brackets in was that so that you didn't lose the case of the minus minus. So that's -1 in disguise. So -1 times -32 is +32. So this is actually 36. The most important thing about that isn't that it's the number 36, it's the unseen thing. Okay, it's +36. Sitting there, obvious as they're not sometimes, the coefficients of the numbers or the primary, whatever the coefficient is, it's the thing sitting in the front, is not always obvious. So our discriminant is positive. Delta is greater than 0, which is a mathsy way of saying delta is positive. And when delta is positive, so that's an analytic phrase. That's analysis that I've used there. So analytic phrase, delta is positive, is greater than 0. So see that sign? That sign is equated with this idea, this maths idea. So being really mathsy now. By identifying the plus sign, you're saying, oh, okay, delta is positive. And the way that we write that in maths, see, what you might say is you might say the triangle is greater than 0. That's the inequality. You wouldn't be wrong in saying that. But that's not what we want. We want you to cognate that when you get anything with a greater than sign to 0, that means the anything is actually positive. Therefore, two distinct, that means different, roots or solutions. So all of that mashes up into completely characterizing this quadratic. So I started off cheating. That was my study plan, to put some random numbers in, to do the expansion to get the trinomial. And then for the trinomial, I went and built the solutions using the completing the square method. Now, if I finish this because I know that b squared minus ac is 36, I can do it the other way. I can say that minus b plus or minus the square root of delta, which is b squared minus 4ac over 2a. So if I populate those values, b was 2. So the best way to do this is just to do some examples. So if you guys are cool with it, so this is the adding fractions part now. Split the fraction. Simplify it a little bit. How you do this last bit is really up to you. So we've got two things. We've got minus 1 plus 3, comma, minus 1 minus 3, as before. So minus 1 plus 3 is 2, minus 1 minus 3 is minus 4. So they're the same solutions that we had at the very beginning. Okay. Is that kind of helping? Is it answering your... Yeah,
it is. Thanks. Yeah.
So what we can do some more. I think it's important now with this, because I'm doing completing the square as well. What I'm trying to show you is that it doesn't matter which method you use. You don't need to get hung up on one or the other. And I actually think it's a good idea. So if you're sitting there studying after we finish tonight, what would be the first step? The first step would be you get these linear factors. So you tell me what the number is. You tell me what to put in there. What's this first number?
Plus 3.
And this one?
Minus 7.
Okay, so we'll do the expansion. So we've got x squared. I'm not going to fit it on there, am I? X squared, so FOIL, 1, first, outside, inside, last. And I can post these Saturday notes. I won't let this go. I'll post it for you. Okay, so we've got x squared. Then we've got outside is minus 7x. Inside is plus 3x. And then 3 7 to 21. So the minus 7 apples plus 3 apples minus 4 apples minus 21. Now the thing is, we don't know anything about that trinomial, but that's your cheat part. Okay. And we also know the solutions. So just be careful when you do this. X equals, we're going to put the opposites in. So you said 3, but it's minus 3 as a solution. And plus 7. So just remember that when you set this up, now often what we do is we go backwards. Factorizing asks us to go from this one here to this one here, doesn't it? You need to recognize that. Now, in all the years that I've been doing this with students, guess what? I don't teach factorizing. I don't care. I'm never going to give you a trinomial like that and expect you to come up with this by using one of the 4 factorizing methods. I don't care. Why? You don't need it. What you do need is completing the square or the use of the quadratic formula. And if you use completing the square or the quadratic formula, you'll win. Okay? It's as simple as that. So I really encourage you. It's a big part of this subject. My colleagues aren't all convinced. So they're still teaching, a couple of examples of factorizing. Let it go. You don't need it. Okay? And the 4 methods of factorizing are guess and check. 2 numbers that add up and multiply. Grouping in pairs is another one. So it's just a waste of your time. It's a waste of your life. All right, so what we're going to do is we're going to attack this in parallel. This is your study time now. We don't know anything about this. If we do the completing the square method, we'll quickly identify if it has solutions or not. But another way, and I said it in the workshop, was that if we had some tool, we could just check it and it would tell us the class of the trinomial. So you've made this up, so that's good. So B is -4, A is 1, and C is -21. So the dots mean times. Okay, so it's good to put a bracket around. So -4 times -4 is 16. Now, 4 times 21, 4 ones are 4, 4 twos are 8. So it's -84, but it's -84. So it's actually 16 plus 84. So it's actually 84 plus 6 is not, it's 100. So your discriminant is 100. Now, what's the telling thing? I've left that deliberately because I have taught you it, but it may not have got in. What class is that for delta and y? What's the big idea behind this last line? You're seeing equals 100. You're probably thinking, so what, Jason? It's 100. That's not the idea. What's the idea?
If I understand right, it's just the sign. And
Yeah, absolutely.
so it's positive, which
Yeah.
means that this should
So
cut the x-axis twice.
that's exactly right. So what we're saying is delta, this is being very mathsy, delta is positive. See that? Encapsulated as a thought. Okay, delta is positive, which means two distinct roots. Now, if our maths is right, when we go on and do the completing of the square, it'll agree with that. So therefore, x is equal to minus b. Oh, we've got to be careful now. Minus b plus or minus the square root of b squared 4ac over 2a. That's our formula. So now b itself is what? B itself is -4. So when we come to use the quadratic formula, we've got to take into account that it's bracket -4. So it's actually -1 times -4. Now the square root, b squared minus 4ac was 100, we worked out. 2 times, and a was 1. So minus times a minus is a plus. The square root of 100 is 10. And all of that's divided by 2. So there's your adding fractions. Hopefully the adding fractions is getting more familiar for you, so you can see the value in it. Okay, so we can split the fraction. That's the same family, it's just the previous. 4 on 2 is 2, 10 on 2 is 5. Oh, look, it's getting there, isn't it? 2 plus 5, comma, 2 minus 5. Okay, so we've got 7, and 2 minus 5 is -3. So that's our solutions. Let's go back up and see. Yeah. Good job. Same as up there. So we read that off. That was our cheat part, but we just discovered it. So if you'll allow me, do this. Now I've got to do -21 minus 4 because you can't plus and minus. Got to balance it. So this is a perfect square now. And it's going to be that -2, isn't it? Let's check it. X times x is x squared. X times minus 2 is minus 2x times 2 is minus 4x. Minus 2 times minus 2 is plus 4. Minus 21 minus is minus 25. And don't forget your square. Now, of the students that are here with me today, how comfortable, if there's one of you that doesn't like me doing it, I want to test this idea. If I just say, I'll do this just to get this over. So that's undo. Okay, so what I'm going to do is I'm going to say, now one of you students, if you don't get this, this is the safest experience you will ever have at university. You must speak up. Okay, please. Now, if I say, how do you undo the square? You take the square root. And if I do this, is there anyone who feels that's inappropriate because I have skipped steps? I need to hear from all of you. So Grace?
That's all good with me. That makes sense.
Solon?
Yes, that makes sense.
Green?
Yep. See what you did.
Okay. All right. Now, who have I missed? Where's my little thing on here? So Ada, you've given me a thumbs up.
Yes, thank you.
Okay. All right. So people bailed on me, so that's all right. All right. So what we can do then is we can do the undo of this. So x equals 2 plus or minus square root 25, 5. And we're here, aren't we? We're here at this point. See, we caught up to that line. So it's 2 plus 5, 2 minus 5, 7 minus 3. And we didn't have to split the fraction the way that we did with the quadratic formula. That already came out. Okay, so there are a parallel way of doing it. I like the use of the fractions and the radicals because when you do some other topics, that's a really important skill. Factorizing couldn't care less. Doesn't impress me at all. Why be given a trinomial just to find 2 bits of it? You know, why be given? I'm sorry if I'm repeating myself about this. Why being asked to factorize, right? And find 2 bits. Why? Why? You're finding 2 bits of a graph if it exists. Okay, so in that sense, I'm just saying I've never taught that because I think it's a waste of your life. All right, would somebody else like to give me another example? Oh, actually, can I do one? I've thought of something I'd like to do. Okay, so let's go for y equals x squared minus x. Now, it's incomplete. It's still a quadratic formula, but it's just silly. So, will it work? Of course it will. Now we haven't got anything else, so we can just do a minus a quarter. Now this is a perfect square in x, and minus a half. That was this one. Let's try it. x times x is x squared. X times minus a half, this is the shortcut, is minus a half x times 2 is minus x. 2 halves and done. Minus a half times minus a half is a quarter. Tick. And that's a perfect square. So can I do the undo? I'll do 2 steps. I'll do the undo 2 and I'll do the undo a quarter. So I'll get x minus a half equals, I put the quarter over. Is that too much? Or are we okay with it? Can you see what I've done? Is there anybody not? Yeah, Grace? Yeah.
All good.
All good? Okay. Okay, so we'll go with everyone. Now, like Ada's thumbs up, but that's okay. All right, so this one here now is a bit of algebra because we can do this. Me being a long way teacher, that's just silly. Jason. And this. So we got there. But we also had x minus a half. So we'll undo that. So we'll add a half. So we've got a half plus or minus a half. This works, you see. It always works. Oh, look at that. That's an unusual, unexpected. A half plus a half is 1. A half minus a half is 0. Now, the factorising pundits would have said to you, assign it to 0, take out a factor. When is that true? Okay, when is it true? Well, if this one's 0, the whole product is 0, because 0 times anything, 0 times brackets anything is 0. So one solution is 0. Oh, look, we already had that. Tick. When is this 0? It's 0 when? What's the x value got to be inside the bracket?
1.
Ta-da. Look at the answers. They're the same. Okay. So if you're in doubt and you get something that's a bit of a challenge, you can do that, or you can come back and do this. It works. You'll have much more power at hand if you can be patient with yourself and do that. Now, of course, it gets even trickier if you get something a bit challenging, like something like this. No, I'm going to take that away. So in this one here, it's a cube. We've been learning about quadratics. So why would you put a question up about a cube? But across the minus sign, is there something that's appearing in both terms across the minus sign? What's the something?
X.
Okay, so we can take the x out. And all of a sudden, we've got a quadratic. It's not much of a quadratic, but nevertheless, it's there. Now, I could have made that a bit. So we do the same thing. You can pretty much work out that x squared has to be plus 2. So if x squared is plus 2, no, I'm doing that teacher thing. You can take this and do that as completing the square. One answer will be 0 due to that. So x will be equal to 0 for that one. And then there'll be this x squared minus 2 would also need to be 0. When is it 0? When x squared is equal to 2. So undo. So you get root 2 and minus root 2. Now you would have found that by completing the square on x squared minus 2. All right. That can also be, another example could be that would be a typical one. Again, what's common across each of the three terms?
X again.
So we can take the x out. We'll get x squared minus 2x minus 3. Oh, okay. So one of the solutions will be 0 because of this. And then we can go and complete the square or use the quadratic formula. Okay. So the more that you practice that, and we can even check delta, b squared minus 4 a c, put a bracket in, 4 minus 12, 4 plus 12 is 16. And what's the significance of that? That is a positive. Delta is positive. That's how you would say that. Delta is positive. Two distinct select roots. We call them roots of the equation. So then we can go off and finish the quadratic formula. We can do the whatever we need to do to get that out. And that'll give us the other two. Do you want me to finish that?
I'm just wondering, Jason, at this point, there's still an x outside the bracket, so does that mean
It's a 0.
this- Oh,
So look at this equation. This is an analysis idea. When is this true? When
right.
is the left-hand side equal to 0? The
Yep.
right-hand side's not changing. One time is when x is 0. Okay. Another 2 times is when this thing's complete. Okay, so we've got to find them out either by completing the square or minus 2 plus or minus the square root. What do we have? 16 over 2. So minus 2 is plus 2, plus or minus 4 over 2, split the fractions. So we've got 1 plus or minus 2, which equals 1 plus 2, comma 1 minus 2, which will give us 3 and minus 1. So the other ones are 3 and minus 1. So you can check that using your function notation. Whenever you get these solutions, you can come back up here and we can put 0 in, 3 in, and minus 1 in, and we should get, what should we get? We should get 0. So in the first one, it's trivial because 0 cubed minus 2 0 squared minus is 0. So that's worked. 3 threes are 9 threes are 27. 3 threes are 9, 2 nines are 18. 3 threes are 9. Minus 18 minus 9 is minus 27. 27 plus 27 minus 27 is equal to 0. So that works. Minus 1. Minus 1 cubed is minus 1. Minus 1 squared is a positive, so it's just minus 2 because 2 ones are 2. And minus 3 minus 1. So 1 minus 2 is minus 3. Minus times a minus is a positive. So we get minus 3 plus 3, which is also 0. Tick. Right. So using your function notation, these are the valuable things. If I'm going to spend time with you guys, this is what I want you to be doing. So I encourage you to look up the Maths Study Centre website and attack those things. Don't do it the way they do it necessarily, but see if you can apply these ideas. So x squared, sorry, habits. Just stop me or change tack if you want. Same. Okay. So building fluency with this kind of solution will pay off in the future in Maths 1. And I don't mind which method you use, but the analogy is complete, right? You're using a lot of the same thing. All right. Did anyone else have anything that they wanted to have a look at? Or, sorry, I didn't mean to say anyone else. I meant else being me. Have you got more? Or do we need to do more? What are we thinking? Kind of flies when you're having fun, doesn't it?
Hello, Jason.
Yeah, go ahead.
I have a question about the homework on the Pearson.
Yeah, okay.
So is that graded towards our grade?
Yeah, it's 1%. If you look up the subject outline, it says it's worth, there's 10 homework sets. They're worth 1% each for an overall of 10%.
Okay, and also it allows you to fix up what you've done wrong, and then you get. So say you get it wrong for the first time.
And I
It
think it
says-
reduces the amount for the second one, doesn't it?
You can do a similar question, and then it goes back to full marks.
Okay.
So I was wondering, is that what gets recorded?
Yeah.
Oh yeah, so yeah, I was spending a lot of time making sure I didn't get any wrong at all, but I think you can, once you get it
Yeah.
wrong, it shows you how to do it properly, and then you do
Yeah.
it properly, and then you get full marks.
Okay. So what's happened in the past? Okay. So anytime I speak about what I'm going to say, it could be interpreted as having a negative reflection about the past. So I don't care about the past because it doesn't matter. I've gone on this crusade to try and get everybody encouraged to do heaps of work and do it in a smart way. All right. And what I know from the past is that sometimes homework wasn't being attempted. And I think you guys that are here today can understand why. Because if you didn't have the kind of information that you've been given in the last 2 weeks, how do you do it? All right. So I think what was happening was, because some of the questions are pretty tough, how do you fix it? Okay. So what I've done with the workshops and the tutes is gone a long way to solving that dilemma. This Saturday session is like the last bit of that. It's to say, okay, if you've got a particular one that you can't do, bring it and I'll have a look at it with you. And I don't mind doing that. I don't mind doing that because it's more important to me that you are able to move forward than get stuck in a hole. All right. This week,
Sorry, Jason.
go ahead.
Can we have these quadratics one that we solve, have it on the this coordinate system as well, so we see how it looks?
Well, that's what I'm saying. That's the thing, right? On this one here, when you do this, you can ask, what is the geometric interpretation? And this is why I favor the other one. What is the geometric interpretation? Okay, it's not wrong. It's not better or worse. It's just what's the geometric interpretation. When we get to here, that completely describes this. As I've pointed out to you, x minus 1 inside the bracket. So I'll draw it here. This is a shifted perfect square. So in the developing process of completing the square, you actually get the sketchable one. Here you don't. You don't get the sketchable one on this side, okay? You don't get it. But over here, guess what? At some point, you get the sketchable one, okay? So this one is actually at, it says x squared minus 1, so it's the opposite. So it's at 1. It's at minus 4. The quadratic form has the x-intercept as a minus 3. And so the quadratic form for this particular part is looking like that. Now, what's important in what I just said is that this is only the quadratic part of a factorized cube. Okay? So if your question is, what does the geometry of that one look like? Completing the square will give it. Just those factors. However, what is this geometric interpretation? Now, guess what we haven't done? We haven't done polynomials of a higher order. So the question becomes, how do I sketch something that's higher than a quadratic? I think that's what you're asking me. So if I'm sketching something that's higher than a quadratic, x cubed minus 2x squared plus 3x, was it?
Minus 3.
Minus 3x. If your question is, how do I sketch this one? Then the answer is, okay, we're not going to be able to do that using the quadratic techniques. So once we skip past the quadratics, it then becomes a more difficult proposition. Now I'm going to do it for you because you've asked, but the thing is here, this is where we have to use calculus. Okay, now I'm going to introduce calculus to you in a couple of weeks. Well, actually, I already have. So if you wanted to show me what differential calculus is all about, what would you be doing on camera at the moment? You'd be doing these ones. My lips are sealed. Okay, so I'll give you some. Now, when you do differential calculus, it comes into curve sketching. And it's not straightforward, but I'm going to do it, not to confuse you or to drive you away or anything like that, but to try and help you, okay? So basically what I would do is I would take the differential, and you don't know what that is at this point, but essentially it's going to be this. And that itself is a quadratic. Now, what I do in the process of taking the differential is I apply the differential, or I set it to 0. And guess what that means? Straight away, I need to solve this quadratic. Oh, look at that. I need to solve the quadratic. Now, you can go and do all your factorizing stuff if that's what you want to do. But what I've said is, I'm not doing that. I'm doing this. Now, you can take the quadratic form. Actually, you know what? To be consistent with what I just did, I'm going to do the line down the page. Because this is now where your quadratics pay off. In a 3 weeks time, we'll be looking at this. 2 weeks time, we'll be looking at this. 3 weeks time. And so now you're getting some insight into the quadratics, okay? So x equals minus b plus or minus b squared minus 4ac over 2a. Over here, we'll do what I did, which is x squared minus 4 on 3x minus 1. Okay, this will become minus 4 plus or minus 4 squared minus 4 times 3, because that was 3, and c is minus 3. So we'll put a bracket there, over 2 times a, which is 6. So doing part by part, minus is 4. The square root. Now, 4 4s are 16. Now, this is funny because we've got, it'll be a minus 1 times a minus, so we'll end up with a plus. But 4 3s are 12, and 12 3s are 36. So it's going to be 36, and 2 3s are 6. Now, I didn't check the discriminant, I just went with it. But that's a positive, isn't it? 16 and 36. So 4 is the square root. Now, what's 16 and 36? 46. 6 is 52. Splitting the fraction. It's not going to come out easily because we're going to leave it as an exact value. So we're going to get 4/6 plus root 52 on 6, comma, 4/6. You might notice I didn't change the family because I wanted to leave the calculation. So we're going to get one solution is 4 plus root 52. That's an exact value. 4 minus root 52. So there are our two solutions. Those points are where we cut the x-axis. Now, something's happening there, so I'll go and get that. But let me do it here because we're going to end up doing the same thing. Let's check it. X times x. Minus 2/3 x times 2 is minus 4/3 x. Minus 2/3 squared is plus 4. Good, got that. Now this is a little adding fractions problem. So we end up with this one. So I can do all the undo stuff, being a bit shortcutty. So I'm just checking this because I feel sometimes I get premonitions that I've made a mistake. -1 minus 4/9. I think we're okay. Okay, so what have we got here? We've got 2 on 3 plus root 13. I think we're okay. Comma 2 on 3 minus root 13 on 3. So the same family. So I get 2 plus root 13 on 3 and 2 on 3. Oops. Root 13 on 3. Okay, so what's the difference? This is 6. So you can clearly see that if we multiply top and bottom by 2, you know, I'll do it because it's a bit of fun. So that's the same as that. It's just reduced. So let me show you that it's reduced. So if I do 2 13 on 3 times 2, I will get on the denominator 6. And I have to do 2 bracket 2 plus root 13. So the expansion for that top bit is going to be like that. So we're going to get 4 plus 2 root 13 over 6. Now, this is an algebraic trick. To get this under the same square root sign, I need to go 4, 13. Why 4? Now, I might have been a bit rude doing that. I better change that to 2 squared. That's easier to see. If you undo 2 squared, what do you get? Square root of 2 squared, it just gives you 2. Tick. Okay. Yeah, that's 4. So bring that line down there. 4 root 13. Now we've got 4 times 13. So that's 4 3s are 12. 4 1s are 4. 52. There it is, you see. It's the same value. So it's an equivalent. It's just that it's looking like something different. And what do we have? If I do the same process here, it'll be 4 minus root 52 on 6. Okay, so those values there are the same whether you do it that method or that method. All right, so we ended up doing that because the differential was to find when is this true. Now this has a special meaning. This is asking m is equal to 0. So what's the gradient? If you do your arms up like that, just humor me, y equals x, where's m equals 0? I don't know, I don't want to ask you to turn your cameras on, but if someone would be willing to show us what's m equals 0, you don't have to. Just wait a minute. If somebody wants to, brilliant, thank you. All right, you can turn it off again. Thank you. Well done. So, and thank you for blurring your screen. That was very courteous of you. Okay, so what that means is that y dash is equal to 0 when x is equal to 4 plus root 52 on 6 and 4 minus root 52 on 6. So as a number, what are those numbers? What are those numbers? What's 4 plus? I can't do that easily because I'm doing my stuff here. Sorry, I'm doing it on my other computer. So 52, take the square root of that, 7.2, put that in the memory. Now 4 plus that equals 11.2, divide that by 6. So 1.868, so let's call it 1.87, 1.9. I'll call it 1.9. We'll call it 1.9. And then if I do 4 minus memory recall, I get minus 3.2 divided by 6, minus 0.535, minus 0.54. So what's happening at those two x points is that, so I got to sketch it now because you asked me there. The gradient at 1.9 and minus a half, let's exaggerate this, shall we? More, 1.9, 1 minus 1, 2, so half's about there, minus 0.54. Now, somewhere on that line is an m value that is flat. So how do we find out where? Well, all we do is use function notation and put that value back into our original cube. Okay, so 3x squared minus, x cubed minus 2x2 minus 3x. Somebody help me with that. X cubed minus 2x2. Is that right? Now what I'm going to do is function notation. Minus 0.54 minus 0.54 cubed minus 2 times 0.54 minus squared minus 3 times minus 0.54. That's that one. And F 1.9 is equal to 1.9 cubed minus 2 times 1.9 squared minus 3 times 1.9. Okay, so what are those values? That's a bit nasty, isn't it? They're the y values. So if we can find the coordinates, I'll show you what the next step is. The next step is we've got to evaluate that. So no, sorry. I want Excel. We've got Excel. Let's have a look and see if we can do that. Okay. Really? We've got to sign in. All right, great. Thanks for that. Okay, let's do another one. Great. Now we've got to put in, oops. How do I put that in? Oh, I'm not stupid. Hang on. I'll do it on. I'm just going to my other machine. I'll get rid of that. Great. All right. So just using, sorry, I'm using Excel just to do that. So I've got minus 0.54 to the power 3. Oh, I could have used Wolfie, couldn't I? I could have used Wolfram. Minus 2. Actually, why don't I use Wolfram? Let me be wrong doing that because I want you to use Wolfram. Okay, come on. Okay, come on. Great. Go away. Come on. Okay, that's better. All right. So somebody want to read the equation out to me? Oh, you can't because I've covered it up. No.
I
Okay.
do have it here. X to the power of 3.
No, I want the actual. Oh, okay. No,
Oh,
sorry.
3x to
No,
the
let
power.
me do it this way. Let me do it this way. I can do it. That's all right. Okay, this one here. Split view. Give me Wolf. That's what I want. Okay. All right, this will be good. Okay. So now I can do it. So that's what I want. So I'm going to do. Oh, what are you going to do? Big. Come on. Get your act together. You're going to do bracket. Minus 0.54. Close the bracket. Power 3. Space. Thanks for telling me that. Okay. Minus 2. Which is our thingy. Put a bracket in. Minus 0.54. 0.54 to the bracket to the power. Come on, where are you? Come on, where are you? To the power. What did we say? 2. Space. What's the next one? Minus 3. It's good that we're doing this anyway. Bracket minus 0.54. Okay, so all of that should give me the y value. Minus 0.54 cubed, minus 2 times minus 0.54 squared, minus 3 times, which it did. 0.8796 represents the y value, so it's positive. So for this one here, if we're going 1, 1, 2, 2, 0.8 is about here. So that's that one. I'll tell you what happens in a minute, but I need to go and do all of that again for the 1.9. Okay, so I'm going to try and do it in a way that's not completely annoying, but good luck, it's me. 1.9. Is this what you wanted? 1.9, and inside there, 1.9. These are approximates, remember? Go. So now we've got the same equation with 1.9, and its result is minus 6.06. And what was the previous one? Minus 0.89 or something. We'll go with that. So there are two values for y. Okay. So here, minus 6 is going to be way down here somewhere. Minus 6. And we'll put it there. Now, what's the gradient at those 2 points? Whew, seems like we did a lot, didn't it? But what we established was that y was equal to differential was equal to 0. That was m was equal to 0 at that number and at that number. Now, if that's the case, m is equal to 0. Now, you've already shown me what the gradient looks like there, so I'm going to draw it. That point has a gradient like that. That point has a gradient like that. Okay? Now, by doing this, what we've established are the coordinates of turning points. Now, knowing these curves as I do, this is how we sketch curves that are not quadratics. So when we're doing quadratics, we've got a lovely thing called completing the square. We could use that to sketch our curves. When we've got non-quadratics that go beyond linear and quadratics, we've got to use calculus. That's going to require us to work on quadratics. So this one here, what I know is that this one here is going to be like this. Okay. Now there's another technique that I don't want to go into today, but essentially you asked me the question. Now let's see if my intuition is working. Because we've got Wolf, we can put it in. Okay. Now tell me what the thing is, please. X cubed.
Minus 2x squared. Minus 3x.
Is that right?
Yep.
Oh, look at that. We're as good as Mathematica. Okay. So what I'm showing you is the power of mathematics. I'm not that far off. Now, I don't know the values of the actual points, but simply by doing that much, I've been able to characterize the curve to quite an accurate degree. So I understand that the curve's increasing before the x value, 0.05. At the x value minus 0.054, it's turning because the gradient is 0. Now, you might ask me, how did you know it was going up? Okay, so I used my intuition and I was fortunate, but there are tests that I could have done. I could have tested some values. I could have tested what the value was like at -1, and it would have shown me if it was up or below. You know, I could have put that into the y equation, and I could have tested at 1 and tested at 2. And if you test those values, it'll land you someplace, and then you go, oh, okay. So it's increasing up to 0.54. There's a 0, so it's stopped and it's coming back down. It's decreasing all the way down to 1.9. And then it's stopped and it's turned around. It's increasing again after 1.9. So Ada, you were a little bit cheeky asking me that question. Did that satisfy your thirst and hunger for knowledge about?
Yes, thank you very much.
Do you understand it?
Yes, very much. Thank you.
Okay. All right. So what will happen in the coming weeks is that I will formalize this process, and I'll do it in the same kind of way. But hopefully, again, without knowing everything we need to know about gradients and quadratics, you're able to see the value of what I've been teaching you about quadratics, with both forms of the formula. Wow, time has really flown. Has anybody got anything particularly pressing, or can we call it?
The recording from yesterday's tutorial, or
I haven't put it up yet, man. Come on.
okay.
Give me a chance.
No, that's it. Thank you.
All right. Is there anybody else that had something, or are you all happy with that?
Thanks for your time, Jason. That was really good.
Okay, this is what I want for you, okay? I don't want maths at university to be a burden. I want it to be fun. I want it to be informative. I want it to be doable. And I want you to be able to just walk with your maths so that you can go from here to there and explore the world through the lens of your degree. And when the degree makes demands of you about the maths, you can rise to it and you can say, you know what, it's all right, I've got this. Okay, that's what this whole subject's all about. All right, guys, thanks for coming along. I do appreciate your attention. Okay, and I will see you next week. Have a good one.
Okay, bye.
Thank you.
No problem.
See ya.
See ya.